I'm just going to deal with cyber threats and risk in blockchain systems. So first a few minutes, what I'll be doing is I'll be doing what are the threats and the risk involved in a blockchain system, and the next half, if time permits, I will be showing you a tool on Solidity. So SOLIDATY, where we can able to generate smart contracts for blockchain systems. So I will be showing you because tomorrow also I am going to deal with the same afternoon session with the attack defense in blockchain. So I'm going to use the smart contract as one of the option for showcasing it. So maybe a brief introduction of Solidity will be a great hands-on for the today's session. So let us move into the cyber threats and the risk in blockchain system. So having said that, since last 2 days, you have been attending this lecture on blockchains. So you might be knowing about what is the need of a blockchain, why we need blockchain applications, case studies, all these things over these years we have been studying, we have been doing, and how secure it is. But there are always, whenever any new technology is there in the market, always there will be a threats, and there are many risks involved in the any kind of system. So blockchain also suffers various threats and various risk involved behind it. So we will see that what are the different risks involved in this cyber threats and the in the blockchain systems. So to start with, just I will just show you a blockchain working here. So we have there are six entities we have. First entity is a transaction. So generally transaction is, let's say if we take two persons called as Anand and Hari. So let's say Anand is A and Hari is H. So we we have two persons. So Anand sends one coin to Hari. So this is one. So coin is Bitcoin is a kind of a cryptocurrency which uses blockchain as one of the blockchain system. So in this case, what we do is the Anand sends one coin to Hari. That is the first one. There is a transaction. That is just broadcast into the distributed channel. Anand signs the transaction with his private key. So generally Anand has a password which we call him as a private key. Private key means it is known only to Anand. So this is what Anand is having a private key. So it is his own private key. He only has access to and he only knows that. So this is the thing. He signed with his private key and then broadcast it. Now after that it goes to the verification. So verification nodes check the signature and the coin balance. So now for this verification, it checks the signature of Anand as well as the coin balance, how much balance Anand has. So all these things matters to Anand here. Now the transaction is grouped with other transactions. Now whatever the transaction, once the coin balance and the signature is verified, the transaction is grouped with the other transactions. So next concept is the grouping. Then the miners compete to find a valid hash for the group. Now, since it is the transactions added to the group, there are some people called as miners. So, which we called as the miners will be creating a valid hash for the group. So, they will be computing various algorithms for finding the hash algorithm, and that hash group, that hash name they are giving to the group. That is called as the mining. So, finally, after the hashing is created for the group, the block is added to the blockchain. The complete block with the group will be added to the blockchain. So this is how the way for every system it works this way. So the entire coins, cryptocurrencies, the many of the blockchain systems will be working on this way. So totally we have 6 entities. Now whenever you deal with the blockchain, you should not forget about the 6 entities: transaction, broadcasting, verification, grouping, mining, and blocks. So these are the 6 things that the blockchain stably work. Now you can see that now here is a generalized diagram. Here the transaction is requested by a Bitcoin. So the B refers a Bitcoin, or we can call a blockchain. The block representing a transaction is created. So after the transaction is done, verified by the miners, and then creating a hash, then it will be a block is creating. So a transaction is created by representing as a block. Now the block is sent to every node in the network. Now after what happens, after the block is created, now there will be so many blocks will be there in the blockchain. So it is something like this. Maybe just so it is something like this is one block. Now this is one block. This is one block. And now what we do is we have added one more block here, and then we again go with this block like this. Okay. Now this block is added. It has to be known to everyone else. So this is what is going to happen now. So this job, the block is sent to every nodes in the network. That means every nodes in the network will be knowing it. Now after that, the nodes validated the transaction. So all the nodes, they validate the transaction, whether the transaction is valid or not, that will be validated. Then nodes receive a reward for the proof of work. So we have something like this POW. So here we have one concept called as POW. So POW is a proof of work. So really we have done it or not, and there are so many computation by the miners. Everything happens at the POW. That is proof of work. So the nodes receive a reward for the proof of work. That means all the nodes receive, every nodes in the network or the computation, the miners, everyone will be getting a proof of work, their reward. Block is added to the existing blockchain. Now the block is added to the blockchain, and we finally the transaction is completed. Okay. So this is how the way the generalized blockchain works. Okay. So now in this case, what could be the cyber threat involved in it? So this is how the way that we are going to see. Okay, from this diagram. So having said that, we have a transaction, we have a broadcast, we have a group, and we have a miners, and we have chain blocks. Everything we have done it, but where the cyber threats will occur. Now this is what we are going to see. Generally, we call as a type of attacks. What are the different attacks we can able to handle in this blockchains? So first thing is the 51% attacks. So generally we call 50%, 51% attacks. So generally 50-50 generally we call. But here what does it 51% attack means? More than half of the thing will be handled by the miners and the adversaries we called. So they will be attacking the system. So that's why this kind of attack is commonly called as 51% attack. In many of the cryptocurrencies, this 51% attack is very common. So even every month or every week, there are so many 51% attacks are happening on the blockchains across the world. So generally on the public blockchain even. So that's how the way the 51% attack is happening. So what does it do? So you can see here a 51% attack is a type of attack on a blockchain network where a single miner or the group of miners gain more than 50% of the network hash power. So what is the hash power is the miners are the one who creates the hashing. That means they only create the hashing with various computations and allocate to the block. So what do they do is whenever they create the mining, so more than 50% of the hash power, they just hold it. So that is we call 51% attack. So that means 51 means not exactly 51. It is more than 50. That means it could be 57 or it could be 58 or whatever we call. That's called 51% attack. Now, this is one kind of thing. Next thing is preventing other miners from confirming new blocks. So there are so many miners. Miners mean those who do the mining. There are so many one will be there. So this attack also preventing other miners from confirming the new block. So it is like blockchain is not added only by one group of miners. There will be many miners will be there. So this 51% attack prohibits or prevents other miners to create a block because only the miners are going to create a block. So that's how the way it goes. Then reversing their own transactions to double spend coins. So it is like reversing their own transactions to double spend coins. So sometimes when a new block comes up, so for example, double spend means again this adds a different attack there. Double spend means I am paying two times. I create a bill once but paid two times. After that one time when I pay it, the second time I won't pay, but I get the reward back. I get the money back. That means what? I never paid anything. So that's called double spend. So first I activate myself as spending two times and get one refund there. But actually I would have spent only for once. That's called as a double spend coins. So that reversal also will be happening in the 51% attack. Anyway, I will explain that in the next attacks. Altering the order of transactions or excluding some transactions from the blocks. So already some transaction might have happened. So I can that the 51% attack can alter the order of transaction. Now when you see Bitcoins, the transaction takes in Bitcoin the transaction takes minimum 10 minutes to complete. It takes minimum 10 minutes to complete one Bitcoin transaction. Now altering the order of transaction, 51% attack if it is there before the transaction is committed, there could be a chance that transaction can be or may be altered with the help of this 51% attack. So that's how the way the seriousness of this attack will be very severe in the blockchains. So it's the purpose is here is why the 51% attacks comes. Then what happened to that? Undermine the trust and confidence of a users and the investor. Those who invest the money on the cryptocurrencies or the blockchains, they will be having mining the trust and confidence is gone over there because of this kind of systems. Okay, but there are many times, there are always when there's a threats are there, we have a prevention also. So in the left hand side we have this, and then the right hand side we have the prevention. So prevention of these attacks. So first thing is increasing the decentralization and diversity of the network by encouraging more miners to join and run their own nodes. So that means instead of making everyone to be the users, so we make number of miners to be more number of miners we have to include into it, so that it can able to make the decentralization. Instead of controlling everything at one point of time, we can able to decentralize everything, and we make the miners to join and run their own number of nodes. That way we can able to say, and use a different consensus mechanism such as proof of stake. Generally we call it as POS. So POS is proof of stake. Anyway, we'll have that what is a POS and what is POW, we have at the end of the thing. So proof of stake consumes less energy, and it can optimize, and but it is not so powerful than POW. There is a proof of work, but the proof of stake we can able to go for a consensus mechanism. Consensus mechanism means if two parties are there, we come to an algorithm saying that how can we exchange the information between them. So that's what we have a consensus. On what basis of security we want to ensure, that's called, we call the consensus mechanism. So in that case we have two methods, POW, POS. We can go for a POS instead of a POW. Then implementing a delay function. Now we can implement a delay function means all the transaction assume to be taking some time before the transaction is considered to be final or before it is committed. So that's what some delay function. So generally when you see even in our bank transaction nowadays, if you transact let's say 50,000 rupees, let's say you do a transaction through your credit card or a bank account, immediately within the next 2-3 minutes you will get a phone call, automated voice call saying that in your card there is a transaction of 50,000. Did you really do that? Press 1 for accepting it, press 0 for raising a concern. So that means there is a delay in the particular transaction money. If you say if you have not done the transaction, then automatically your money will be reversed to your account. So this is called as the a delay function. So yeah, here also transaction will be delayed a certain amount of time for having this. Then monitoring the network activity and alerting the users of any suspicious changes in the hash power distribution. Generally, whenever the hashing has been distributed to the blocks or the nodes, then we have to keep on checking the activity whether everything is going in correct or not. So this is where the prevention of attacks can be minimized on 51% attacks. So generally, this is what here half of the attacks in blockchains are happening through this 51% attacks only. Now, the Sybil attack is a kind of a 51% attack. Generally, we call it as a Sybil attack. So, Sybil attack is very common in networking. Generally, we call it is networking. You can see in the left hand side, I have a diagram. Blocking users from networks, compromising privacy of a blockchain, network disruption with 51% attacks. So, Sybil attack is also called as a 51% attack. And here, the prevention methods are same. The right hand side, everything, whatever we have seen, 51% it is same, the prevention method. But here, the Sybil attack is a single node or a group of nodes create and control many fake identities. Sybil means what do they do is they will be sitting inside as a miner, and they will be controlling many other fake identities in the network, so that whatever transaction happening inside the network will be relying only within them. So it never goes to the original set of blocks or original set of nodes. So this is what a Sybil attack can. A Sybil attack is very dangerous in the networking because a packet was sent from a source to the destination, it never goes to the destination because in between the attacker nodes will be handling the packet themselves. That is what happening here. Now here in blockchains we have blocking or censoring other users from the network. Now here the Sybil attack do blocking or censor other users from the network. That means it will directly block some of the users who already have a number of coins or number of chains, who number of nodes who own, they can be blocked. Then carrying out a 51% attack. The Sybil attack can able to trigger a 51% attack which can reverse transaction, double spend coins, or alter the order of transaction, like we have seen in the previous slide. Compromising the security, privacy, and anonymity of the users by obtaining their IP addresses and other information. Now, this is what very challenging here. The IP addresses and the other information about a particular users will be revealed to the attacker nodes. So this is what the very challenging here, because next time when they want to do, they can able to tamper their IP addresses as per the other IP address, and they can able to initiate the transaction. So that's how the way the Sybil attacks is very powerful, and that can trigger a 51% attacks. So these are the different attacks, and prevention mechanism is again proof of stake, and implementing a delay function, then monitoring the network and increasing the decentralization. So this is what done in the Sybil attacks. Now, next thing is we go for a double spending attacks. So double spending attack, you can see here in the right hand side, you can see the diagram. There is a buyer. A buyer purchased one Bitcoin. That is only one Bitcoin it purchases. So that means for the one Bitcoin, he has to pay the money. But what he do is he initiate two transactions, T1 and T2. Okay. So the transaction, the Bitcoin is initiated two times of bills. That means, so the bills are generated twice. That means what happens is, first time the bill is generated as T1 and second time it is T2. Now it is coming to the pool of connections here. Now here the pool of connection, all the transactions are here, unconfirmed transaction pool here. Now in this it is unconfirmed. Now after that it sends to two peoples. One is Alice and Bob. It sends to two peoples. Okay. So now in here what happens is wait for confirmation and here also wait for confirmation, both the places. Now this transaction accepted, whereas this transaction rejected. Now what happens? The Alice, he's a buyer. He's buying a Bitcoin. So Alice, he just got it. So Alice approved it. So then he's a buyer. So he pay the money, he get the coin. Okay. But here Bob also rejected. Here not confirmed, so rejected. It is rejected. But it is as per the timing, it is rejected. But what happens is, since one time the transaction is already occurred, and the second time it got rejected, this rejected transaction comes here to the buyer and it feels that refund. It got refunded. So what does it refund is? So he's just going to purchase only one Bitcoin or a one block or only one block he is going to get it. But already Alice approved it, so he paid the money for that. But since it sends to Bob also, yeah, the same bill generated two times, it sends to two people. Now he's trying to spend for twice, but he spent only once. But even then, it assuming that the transaction failed and it will be refunded because it is failed. The successful transaction already, so what happens is he get a coin as well as he got a refund. That means he have not paid anything from his pocket. So this is we called as the double spending attacks. So this attack is also very common in the earlier days of blockchains, but now also then and there are some crypto coins are suffering from this double spending attack. So that means a buyer is initiating two or three times it is billing. So only for one time he get a coin, but the remaining three things he get a refund. So this is what happening in the double spending attacks. So these attacks are very common compared to the 51% also. Now we can see when someone alters a blockchain network and inserts a special one that allows them to reacquire a cryptocurrency. That means reacquire means they can reacquire a cryptocurrency. That means they get a cryptocurrency as well as they get the refund or the reacquiring of it. So this is what we call as the double spending attacks. So double spending attacks can happen, but it is more likely that a cryptocurrency is stolen from a wallet that wasn't adequately protected and secured. So if a double spending, if a cryptocurrency or a blockchain is not being protected and secured, so there could be chances of a cryptocurrency being stolen by paying only once. So okay, now in this case, now since it is two times, so one time either he get a refund of money with one coin, or sometimes he can get for one time payment he get two coins. That means he's stealing a cryptocurrency. So this kind of attack we generally call as a double spending attack. Now many variations of attack could be used for double spending. 51% again, it is one of the thing. Unconfirmed transaction attack is most commonly seen. So unconfirmed means generally there are two transactions in the previous slide. So one is confirmed, another is unconfirmed. So generally the unconfirmed transaction generally is more commonly seen in this double spending attacks. So this is what happening in this DS double spending attacks. Now there are several ways to prevent double spending attack. One is decentralization. Decentralization again we have seen that we include more number of miners into the system. So generally what we do is we go with more miners to be included. Consensus mechanism is the consensus algorithm generally we call POS, that is proof of stake. That's what the POS algorithm. Then immutability. So that means prohibit the blockchain in changing the things. So that is immutable. and cryptographic security. So generally increase the cryptographic security for complete blockchains. Then waiting for confirmation. So generally for confirmation, you just wait. So the confirmation can be a PIN number, or it can be a passcode, or any kind of confirmation. We should have it so that the double spending can be avoided. High network hash rate. So this is again on the high network hash rate. A blockchain with a high combined computing power from miners makes it extremely difficult for an attacker to gain control and manipulate the chain. So high network hash rate. So this is what one method of preventing. High network hash rate means, so the hashing function should be running at a higher rate so that the number of hash functions created, hash code created will be more. But the main problem here is the heavy computation is needed. So heavy computational power is needed. Heavy computing power. This is the problem with this high network hash rate. So using these techniques, we can able to avoid the double spending attacks. So generally in the world, there are so many crypto coins are there in the market. So many crypto coins, because of one attack, the crypto coin completely gets nullified and then it goes out of the market because of these kind of attacks. Though we are claiming blockchain is so secure and so rigid and so rugged, but still because of these attacks, there are many blockchains are been closed in the market, and then just they go from the very infinite to zero in simply with just one attack. Okay, so next thing is it's a routing attack. You can see a routing attack here is it is like a routing attack means in the network. So generally the network, these kind of attacks happen. Now you can see in the left hand side I have a mining pool here, and here the stealth connection. Here there is something wrong in this connection here, and you can see that the Bitcoin connection is in blue color. So all the codes where I draw in blue, see that I am just drawing in my blue. All these things are Bitcoin connection. So it is a legitimate connection. So here it is, here, 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 and here and here. So these are the Bitcoin connection. Now private pool traffic here is, so there are some private pool traffic here. So this is the private pool traffic. So means this is a private, this is private, this is private, and these are all private pool traffic. That means inside the mining pool and inside the stealth connection, this private pool traffic is running. But there is one thing called as hijacked connection. We call as in red color, we can see the hijacked connection. So see the hijacked connection here, I am just drawing here. So this is how the way the hijacked connection here. Can you see that? So this is the hijacked connection. So here in this case, the AS8, we call the AS8, just hijack the complete connection of it. So that means whatever goes from one mining pool to the to the Ethereum or whatever the network, whatever it goes, it is been hacked by a in between node called as AS8, which we call as a routing attacks. So when routing itself, they could be able to attack the complete system out of it. So now let us see into it. So this is something technically on a networking part of the, like all of the things on happening on the chain or on the nodes and the blocks in the chain, but here this attack happening on the network. Okay, so an adversary manipulates the network traffic to interfere with the communication between the nodes. So between the node to node communication, the traffic get erupted and traffic get corrupted, and this handled by the adversaries or the other attackers, isolating the nodes or group of nodes. So generally they make the nodes to be isolated, and the group of nodes will be isolated with the rest of the network, also known as partitioning or eclipse attacks. So generally they are called as eclipse attacks. So eclipse attacks means, so they will be attacked. It is something like this we have seen na? So something like this, this is the eclipse attacks, or these are the eclipse attacks. So that means they are just been partitioned from their existing network to out of the control. That is for the eclipse attacks. Then delaying or dropping messages between the nodes. So that means delaying or dropping messages between the nodes, also known as censorship or denial of service attack. So now this is called as a censorship or DOS attack. Generally we call in networking, we call something called as a DOS attacks, denial of service attacks. So delaying a message between the nodes. So the message has to be gone immediately, but the message get delayed. Because of that, the receiver node doesn't know what happened in the transaction, so the transaction may be stopped in between. So these are the different things happening in the routing attacks. Then altering or injecting messages between nodes, also known as tampering or impersonation attacks. So generally we call impersonation attacks, and here we have a denial of service attacks, and we have here eclipse attack. So these things it happens. So impersonation attack, that means injecting messages between nodes, altering. So altering means instead of one message, the attacker nodes will be sending the different messages. So completely the messages were altered. Then a routing attack can compromise the security, performance, and consensus of a blockchain network, as it can affect the propagation of transactions and blocks. So completely, the routing attacks will be tampering the entire chains here. Okay. So now again we have the same thing, decentralization. It is one thing. So main makes more number of miners to join to run their own nodes. In that case, they can able to handle it. So everything happened because of the less number of miner nodes. So that is a main problem. Second thing is using encryption and authentication mechanism like TLS and VPN. So TLS means transport layer security. So TLS is transport layer security. So this is TLS. VPN is virtual private network. Virtual private network. So using these kind of thing to protect the network traffic from eavesdropping and tampering. So from tampering and eavesdropping means overhearing. So these things we can use these encryption standards for making the prohibiting the eavesdropping and the tampering. Then as usual we go for a delay function which requires a certain number of confirmation before a transaction or block is considered final. So before a commitment or before committing, we have to see whether it's happening after a delay, not immediate. So this is what the delay function. And finally, we just keep on monitoring the network because it's dealing in the network layer. We have to keep on monitoring how the network is dealing with the routing attacks. So this is the next kind of attack. Generally, we call it as the routing attacks. Now here, private security attack. So private security attack is like compromising your password. Compromising your password. So generally, this is what the private security attack. So private security means I have one password with me. I think that nobody knows the password other than me. But if some places, if you go to a, let's say if I go to a public browsing center or some colleges, or if I go and use my password, so that password may get leaked outside and somebody can able to get hold of my password. This is one method. Another method is having a common password across all domains. Having a common password across all domains, all portals or domains. So in that case, if you have the same password, same private key of your blockchain private key, it's same as that of some other username or password. If you have it, then at one location, if it is unsecured, then that your private key is at, at the attacker's hand, so that they can able to tamper anything they can able to do. So this is what happening in the private key security attacks. Now let us see. So generally, a private key security attacks are a type of attack on blockchain network where an attacker tries to obtain private key of a user wallet, which is used to sign and authorize the transactions. So generally, for use to sign and authorize, that's a private key which is getting access to it. If the attacker succeeds, they can access the user's funds, transfer them to another address, or perform other malicious actions. So whatever they like, they can able to do on it. So how that comes? First thing is through phishing. Phishing means sending some emails to click a particular link, and once you click the link, they will be getting hold of it. That is one phishing. Malware means using your keystroke. Using your keystroke or some kind of software remotely, they will be telling you to type something. When you type it, the typed signals will be converted into keystrokes, and those strokes will be sent to the person who just install the malware on your computer. So phishing means unwanted emails to be clicked. Unwanted emails. So that's the way this thing. Next thing is brute force, is using trial and error method. I'm just keep on trying with the multiple attempts to guess the password or something. So that's a brute force. Brute force, once beyond 12 digits character, it is tough to crack, but up to 12 digits, it is easy to crack. Easy to within a day or two, we can able to crack it using brute force. So that is one. Then physical access. So physical access is it is something like somebody stole your password from your wallet, or somebody have access to your computer, or somebody have access to your mobile phone where you store the private key of your blockchain, and they can able to steal it. So in those cases, this private key can be attacked. So the main method, the main prevention here is use of a strong and a random password. So generally we go with suggesting to go for a strong or a random password or a passphrase for the private key and changing it regularly. So that is one. Keeping the private key offline. That means generally you never store it in the place where the internet is available. So that means if any machine or a system is internet access, you might have given permission to read all the files. So somebody can read and then somebody can able to download your data. So in that case, keep it offline. Encrypting the private key with the another layer of security. So generally encrypt with another layer of security so that whenever someone wanted to take your thing, so they have to input another key to get into this private key. So backing up the private key in a secure location and avoiding clicking on suspicious links. So generally, this thing is very important. Whenever you do something, avoid the clicking on suspicious links. So in these cases, the private key security attack can be prevented. So that is the next kind of attack. So far we have seen different attacks, 51% attacks, then Sybil attacks, then double spending money attacks, then routing attacks. Now we have private key security attacks. Then finally we have one of the thing is called as vulnerable smart contracts. So vulnerable smart contract. So generally what is by contract is an agreement between two persons. So we have a person A and we have a person B, and between them between the two we have a contract. So this we call as a contract. So generally if you see a contract between one house owner and one who is coming and staying over there. So we have a contract of 11-month agreement or something. So that's what we call it as a contract. So on some terms they will be accepting each other and they will be filing a contract. So how that contract will be evaluated and how because of the contract, how we just can do something on smart contracts. So in that case, what is this vulnerable smart contracts? Okay, maybe if possible, today will show you a demo also on this, on the vulnerable smart contract. Will be showing you. But anyway, just before that, you need to know about contracts. Okay. So generally, blockchain implementation is generally happening with the help of contracts. Generally, we deal with the contracts. Earlier, we were struggling to create a contract, but we have a contract now. It's very easy to create a contract using a tool called as Solidity, mainly for Ethereum contracts. So Ethereum blockchains, the Solidity is a one tool we can able to create a smart contract using the Solidity, not Solidify, Solidity, TY. It is a tool. Okay. So now how we make it is a vulnerable smart contract. We will see those things. Okay. So now in this case, vulnerable smart contracts are a smart contract that contain flaws or bugs in their code. So generally, we have a flaws or bugs in their code. That means contracts have some kind of errors in the code which can be exploited by malicious actors to manipulate the contract behavior, steal funds, or cause other damages. So the fund can be stolen, the behavior can be manipulated, or any other damages can be occurred if there are bugs or flaws in their code. So let's say you are giving an agreement on a contract with let's say a party A signs a contract with the party B on 11-month agreement. So assuming that there was no information about after 11 month what are the things you are supposed to do. Let's say the tenant what he is supposed to do after 11 months. So if there is no information about it, then the tenant can able to retaliate. So in that case, there is a bug or there is a flaw in a particular contract. So contract should be carefully designed and carefully framed. That's why we have a separate programming language for the contracts, smart contracts. Now there are different kind of vulnerabilities that can affect smart contracts such as first thing is a reentrancy. Reentrancy. This occurs when a smart contract calls another smart contract in its code, and when the new call is finished, continues with the execution. Scammers can steal these external calls and make a recursive call back to the contract, thus allowing them to drain the contract. So it is like one contract calls the other contract. So generally in Solidity, I will show you this tomorrow. Possibly I will just show you that because tomorrow session is completely on hands-on session. So here one smart contract calls the other smart contract in a code. Since it's a programming language, how we can able to do is let's say I'll just open another terminal. Okay. Okay, fine. So let's say we have a and we have a B. Okay. So let's say A is one contract and B is another contract. So this is contract one, and B is contract two. Contract two. Now, for some reasons, what I do is here this A is called here. A is called here. So the A is been called here in B's contract. So B is a contract and A is been called here. That means what? The A is called. After the A is done, the contract again returns back. The contract returns back here and B gets completed. Now what happens is there is some more person, the minus will be here. What they do is when this contract is going on, they get access to B. So access to B. Access to B. So that means this minus, they were the minus, they get access to B. So in that case, what happens is after the A or the before the A is been goes again back to A, the callback is going back. Then within that time they will get access to this contact number B, because they were somewhere inside this contract. This access, this minus were somewhere inside the contract of A, and they get hold of the B contract. Now once they have the contract is ready, they could be able to withdraw all the funds, or they can able to nullify whatever they like. They can able to do. So this is called as a re-entrancy, a re-entrance attack, re-entrancy attack in smart contract. So we will see a demo tomorrow on what is a re-entrancy attack and how do we rectify that. So that we will see so mitigation of attack. We will see tomorrow session on this. Okay. So this is on this re-entrancy. This is the first kind of attack that we can able to handle it. Okay. So this is a re-entrancy. Next thing is we have overflow or underflow. So these occurs arithmetic operation exceed the maximum or minimum values of the data types, resulting in incorrect or unexpected outcomes. Scammers can exploit these errors to manipulate the balance of supplier tokens. Now it is something like this. This also I can show you the overflow underflow. Now for example, if I take let's say totally 128 elements, which is equal to 2 power 7. So 2 power 7 equal to 128. So totally what happens is 2 power 7 is 0 to 127 totally. If it is 0 to 127. The first element is 0, last element is 127. So it is on a positive, that is unsigned. Unsigned integer we call 0 to 127 totally for 7 bits, assuming that I am taking 7 bits. Okay, if it is a signed integer, then my value is minus 63 to 64. So maximum value is 64 and here the minimum is 63. Here maximum is 127, minimum is 0. Okay, now what I do is, let's say I am just having one variable called as cost equal to in the unsigned integer cost. So what I do is uint 7, there is 7 bits, cost equal to cost I am just initiating, and after that somewhere else cost is I am giving as 129. So 129, which is a wrong value, because 129 this doesn't know it is wrong. Why? Because the maximum value I can handle is only up to 127. So 129 is wrong. So this is called as overflow. Overflow. So this we call as overflow. Now suppose if a contract have a bug like this, if assuming that it's a smart contract, when I write a code, if I have a bug like this on this this is a overflow. So because of this, the contract will slightly struggle to deploy. In that case, if there are attackers inside your network, they could be able to tamper it, and they can able to whatever they like to do, they can able to do. So this is what the overflow or the underflow attacks. So overflow means over and above the maximum value. Underflow means the lowest value possible. So this is where they have the they can able to manipulate the bound balance or supply of tokens. So this is how the vulnerable smart contracts in the second type of attack is there. Actually, there are many types of attacks, but I have taken only some of these attacks here. Third one is access control. Access control, as we know that who controls what and who is dealing with what. So this occurs when a smart contract does not properly restrict the access or permissions of certain functions or variables, allowing anyone to execute them or modify them. Scammers can exploit these errors to take over a contract or change its store. Now let me show you one example here, access control on the smart contract. Anyway, if this also I can show you tomorrow for the demo. So this is called as access control. Now let's say let's say I'm just giving one contract, one function called as function compute salary. If there is a function, then after that I can say it is public. I can say public. So this is the contract here. I can say public and then easy. So computing the salary is a function written in a smart contract. Okay. So this is one of the smart contracts written there, and now I make it as public. So there are three different access variables. Private, public is there. External is there. External means that can be called only by the external contract. Public means any other contract in the public network can able to compute the salary. This function can be called. Now this is actually a flaw. This is actually a flaw. Having public is a flaw. Now it should be private. The private is correct option, but having a public is a flaw there. Now once this is there, that means this compute salary or whatever be the critical function that can be given access to everyone else in the blockchain, or everyone else who have a control of the contracts. Everyone can have a control. In that case, it's becoming a vulnerable smart contract. So it becomes very vulnerable to the network. So this is called as this access control. Okay. So third thing is timestamp dependence. This occurs when a smart contract relies on the timestamp of the block to perform certain actions or calculations, which can be manipulated by miners or other parties. Some scammers can exploit these errors to influence the outcome of the contract or gain an unfair advantage. So this is a timestamp dependence. So again, timestamp dependence is, so let's say now I will tell you one example here again on the smart contracts. So timestamp. Okay. Now one example here is, now the time is around 2:44 p.m. and the seconds I don't know. Let's say if it is 33 seconds. Okay. Now this is the timestamp. I just have it. Now let's say I have done some operations here, but 244.35 the system corrupted. Okay. So this times and the system corrupted. Now after that the system is not working. So not working system, the blockchain or contract is not working, for example. Now I want to go to the safest state possible. I want to go. Okay. So in that case I need to go to this timing, because this is the time up till which the system was working fine. So system fine, working fine. It was working fine. So I want to go to this state. Now after this 33, 34, 35, so if the stalkers can able to get hold of it, they could able to tamper the data. So based on the timestamp dependence. So we wanted to go back in time. So in the time by which when they moving from there to there, in between the stalkers can able to get hold of this. So get hold of the contract, because the system is down. So they can able to tamper the contract before it goes to the timestamp. Now what happens is the contract is changed and the system goes back to the previous stage. Now the contract is already updated. In that case, what happens? The contract will be the changed contract will be reflecting in the working system there. So now that's how the way the tampering will be happening in the based on this timestamp dependence. So that's why generally whenever we deal with that, always there's a timestamp involved in it. So again, all the contract will execute with some different amount of timing. So that's why this timestamp dependent should be one of the option there. So we have reentrancy, we have overflow, underflow, we have access control, and we have timestamp dependence. Now, having said these things, what are the different preventions for these vulnerable smart contracts? Now, here comes the preventions. So it is to prevent or mitigate vulnerable smart contracts, such as what are the different things? So using a secure and reliable programming language such as Solidity. So Solidity programming language is reliable and so secure. So these kind of programming languages you need to write it, and for specifically designing the smart contracts. So it has many built-in features to prevent common errors. So even if you wrongly write a program, if there is any error, the contract doesn't run, does not get deployed, because it will be showing a error. I'll show you that example also how it shows. Following the best practices and standards for smart contract development. So again, the best practices and standards to be followed for deploying a smart contract development, such as modifiers, libraries, inheritance, interfaces to improve the code quality and readability. So you need to be very careful enough whenever you want to deal with the smart contracts. You need to be very careful enough to write a coding. So generally, I have seen that many places, generally in the law, so in the law means in the legal proceedings, law and the legal proceedings, the smart contracts are been generated using some tools. Okay, many of the tools they are not secure or they are not using inheritance or there are so many flaws or bugs in the tools, but people just use a tool because they are not heavily relying upon programming. So they start using the smart contract development. What happens at the end of the day is if some bugs or flaws are introduced in the system, automatically that contract become vulnerable that they are not aware of. But after some point of time later, it becomes because of vulnerability. There are so many cash insufficiency or the funds will be completely erased from blockchain. So all these things happen. So always someone with the programming knowledge should be writing the code of a smart contract. So generally in the Solidity. So this is what one basic mechanism of it. That's why they said that the Solidity can be learned in just a day also. In one day also you can learn it. But if you want to write a complete good contract, smart contract, it takes minimum 1 year. But keeping that in the all the 1 year, you have to keep on working on this smart contract development. So that's what people suggest that once you learn Solidity, you be there in the Solidity domain for at least for 1 year to write a contract that runs on a public blockchain network. So the only then you can able to have a good smart contract available. Else, whatever you write, it could be vulnerable. So testing and debugging the smart contract code thoroughly. So this is what very important, testing and debugging using various tools and frameworks such as Truffle, Remix, and Mocha, Ganache, all these identify and fix any errors or vulnerabilities. So there are some tools, automated testing tools, so they can able to find out whether your smart contract is vulnerable or not. And you can go through manual debugging also, and testing is mandatory for it. Then conducting a smart contract audit. So generally auditing is also preferred for the smart contract, which is a systematic and independent review of the smart contract code by a third party expert to verify its functionality, security, and compliance. So that's how the way the smart contract can be becoming. It won't be a vulnerable. So if you want to perform all this testing, so testing methods, debugging, then best practices and standards, then secure and reliable languages you need to use, and conducting an audit. So all these things makes the smart contract safe to use. So this is what the last attack that we have. That is, these are the cyber threats. So the totally we have seen 6 kind of cyber threats. So Sybil attack, 51% attack, a double spending attack, routing attack, private key security attack, and vulnerable smart contracts. So now, having said the cyber threats, now what are the risk in blockchain systems? So risk means now we have shown about the cyber threat means what are the really the threats available on a blockchain. That means inside a chain or in the network, what kind of cyber threats are possible. That we have seen. There are more number of cyber threats are there, but let's see how these things will be. Let's see. Okay, so generally in this vulnerable smart contract in 2014, there was one person who just stole around bitcoins, many bitcoins based on one smart contract vulnerability. Okay, so that's how the way in 2014 there was it. But after that, there were many occasions where these kind of attacks are quite common. So based on the people what do they do is once you are becoming ready on finding the bugs and vulnerabilities on many systems, they keep on checking the contracts. So how do we enter into the blockchain? Through the smart contract. So once the smart contract, if they know the flaws or the bugs, then they can able to play around to get the so even in one time on one blockchain account becomes zero. That means they already have some amount of coins inside it, but because of this vulnerability, somebody stolen the complete coins, and that the freezing account just have only 0 coins left after that. So that's a huge money loss for a particular person if the contracts are so vulnerable. So that's why we have to be careful enough on handling this prevention of the smart contracts. Now, risk in blockchain. So, what are the risk in blockchain? So, generally, we are simply telling us a blockchain. So, now many times we see students doing project in blockchains of healthcare analytics for healthcare, and then electronic health records. So, generally, some of application you can see electronic health record system. Many research is going on like this. Then vehicular health record system. So, there's going on like this. Then insurance on this insurance sector in the healthcare in the blockchain systems. Likewise, when you see many places, and stocks in blockchains, then pharmacy in blockchains, so doctor information in blockchains. So there are many things they are telling in blockchains, but what are the real risk behind it? So having opening a blockchain, what does it cost? What does it cost you? Now this is where we have the risk that is involved in the blockchain. So there are many risks there, but I'll be explaining you, because whenever you do your work on blockchain, whenever you do projects on blockchains, identify all these risks in your research, and then you try to make your safe and a secure blockchain system where there will be no vulnerabilities, no attacks, no cyber threats, and no risk. That's how the way. Now let's go into the risk. First thing is, blockchain protocols are hard to integrate. That is the first one. So blockchain protocols. So we have so many protocols, consensus algorithms. They are all very hard to integrate. That means what? So very tough to handle it. Now assuming that we know that there are two kinds of blockchains in the world now commonly. One is Hyperledger Fabric, another is Ethereum. So there are the two things, Hyperledger and Ethereum. Now let me go into this now. Let's say it is Hyperledger. So HL. This is Hyperledger and this is Ethereum. ETH. Okay. Now let's say I have one protocol here. So this is protocol, and this is one protocol. So this protocol writes in this language, and this protocol in blue color. Okay. Now let's say I want to migrate the code. So let's say I want to migrate. So this migration doesn't happen because this protocol is different from this protocol. Both are completely different. So what should I do is I should go for one interface. So what do I do is, now first this has to go here, then after that this will be going here. So through an interface only these things will go on. So this is the converter from Hyperledger to Ethereum. So this is the main problem with the protocols. So because we have commonly we are telling two kinds of blockchain, but there are many blockchains in the industry. But whenever I deal with this, so I need to go the protocol from Hyperledger to protocol from ETH. We cannot go have a direct conversion, which is not possible. We have to go via an interface. This interface is too complex to design. It's too complex to design. So this is what the major risk in blockchains. So because see, now that's why before the session also I asked that Rakshita ma'am about that, what tool the other members are using. Because if you go with Hyperledger, I also prepare the contract for Hyperledger. If you go with Ethereum, I also come with Ethereum. But people suggested most of them are going with Ethereum. So I prepared myself on Ethereum. So Ethereum goes with the programming language called as Solidity for the smart contract. So I also got preparing for the Solidity. So that's how the way it works. Suppose if I learn everything in Hyperledger, and if I want to come here, then what I do is, I don't know anything about Solidity. Then if I know everything about Hyperledger, then conversion from Solidity to other contract is very tough. So this is what happening in the first risk involved is this, how that. So in that case, whenever you deal with this kind of systems, first you have to feel whether what kind of protocols you want to go for. So that's why it said blockchain protocols are hard to integrate from one blockchains to other type of blockchains. So this is what the main issue in blockchains. Okay. So this is the first risk that is involved in it. Second thing is lack of standardization. Okay, now you can see that in the diagram what I see this. So he is just pulling a rope. He don't know how the rope looks like. You can see that how the rope looks like. He do not know, but he is just pulling it. It could be tangled, or it could be. I mean, in between there is some disconnection in the wires. He do not know because there is no standards there. So now the blockchains are not sorry not standardized. Now this is the main problem in the blockchain. So they just lack the standard. So that is the main problem in the blockchains. So that is the second risk involved is if you deal with any standards, then it's good. But if you don't deal with the standards, then how do you handle the blockchain? This is what the major challenge in the blockchains. So next thing is poor values of cryptocurrencies. So now having said that, 2 years ago the cryptocurrencies were very great in the market, but last 2 years, I mean from 22 onwards or 21 onwards, the cryptocurrency market was too dull. That means the cryptocurrencies were not growing to a rate like how the stocks are growing. So the market capitalization here in billions, you can see here red color and the green color indicates it is other kind and bitcoins. You can see that when compared to the other coins growth, the bitcoin growth is too less. So because of the poor values of the cryptocurrencies. Okay, so in the last 2 years there was not a marginal increase or a great increase we cannot commit. It was only a very lighter increase in the blockchains, so in the cryptocurrencies. Now this is where this is one of the main problem in the cryptocurrencies. Now for example, so let's say if India wanted to create a blockchain for the entire citizens of the country. So in that case, just think of what kind of risk involved in that. So how do we segregate into state wise? How do we segregate in district wise? How do we segregate into voters list? So there are so many things that is involved whenever we deal with the blockchains. So first thing involved is this thing. So the lack of standardization. Next thing is we have this protocols integration is tougher, and next we have the poor value of cryptocurrencies. Okay, so that is next one. So next one is high energy demand. So high energy means how much the power is consumed. So that is a high energy demand. I think someone switch on your camera. Someone okay. Hemalata ma'am, you just switch on your camera. Hemalata, Professor Hemalata. Okay, fine. I think she still is not switched off. Okay, fine. So high energy demand. So high energy demand, now again, just let me tell you that on high energy demand is, so generally high energy demand means, so how do I say high energy demand in thing? So now here we have, so high energy demand here set. So generally if we say Intel i7 12th generation with 4 gigahertz. So if you have this 4 gigahertz, Ranjit, Ranjit. Okay, so Intel i7 12th generation 4 gigahertz. So now it is 4 gigahertz. Now the power of the energy is directly proportional to frequency square. So the power is directly proportional to frequency square. So that means what happens here is when the frequencies increase, the power is directly, in that case the energy equation will be very high. So if for every frequency increase, the power is going in a very high range, power and energy will be very high. So there will be high energy demand in the blockchains. So this is the main risk involved in the next aspect of it. But here we have two kinds of works here. So the two kinds is proof of work and proof of stake. So there are two things: proof of stake and proof of work. So proof of work says that uses a competitive validation method. So generally for any transaction or contract validation, the proof of work says that it is a competitive validation, means it goes through all the validation method and find out the best one. So that is a competition involved between the contracts. So that is a POW. So it relies on crypto mining. So generally it is doing the mining. Mining means going through the consensus algorithm in greater numbers and perform so many operations, finding in a hash code, then it will allocate to the block and the block put into the thing. So for all these things to be done, we need a heavy energy, we need a heavy computational resources. For that we need to use high energy demand. So that's the main thing, but it is more secure. The proof of work says that it is more secure. More energy consumed as miners need to solve complex mathematical puzzle to validate. So that is the reason behind we need a heavy energy. But now recently the consensus algorithm comes at a proof of stake (POS). Uses randomly selected validators to confirm transactions. So generally what we do is just randomly we just select the validators to confirm the transaction. So if a transaction is committed, you just randomly select some validator to validate the transaction. So it is something like when you purchase a house agreement. Okay, when you go to purchase if you let's say go for the house registration in the district office or somewhere, if you go, you will always take somebody to authorize that you are present there in front of them, you signed something like that. So it is like a randomly selected validator to confirm the transactions. But there in the POW, you have to go for a competitive method. Competitive validation method means you need to go through all the transactions, do the evaluation, and then you do the validation. But here it is randomly selected. Relies on crypto staking. So makes the crypto relies on crypto staking means instead of mining the crypto, you just make the staking to wait for some time before you take a decision. It is something like a delay function. So just making a crypto staking. So hold for some period of time before it get committed. That is what crypto staking. Next thing is it is more secure. Both are more secure. The POS algorithm allows for a more scalable blockchain with increased transaction throughput. So it's a more scalable blockchain. So here it is scalability is more, but whereas the scalability is less over there in the proof of work. So this is the third risk that involves called as high energy demand. So whenever you deal with the energy values, so you need heavy computational resources. So implementing a blockchain is not an easy task for a given work or a given thing. So that's where we need a huge amount of energy to deal with it. So there are other risks involved in the system. We call it as trusting blockchain managers and developers. So it is something like trusting the blockchain managers and developers. So that means you have to trust the miners, the developers, and whatever they do is correct. So this is where the main risk involved in it. So let's say one example here is now you all there. I am just taking a workshop here. Okay. So if I give one program, let's say in the next half an hour I will give one program. I give a contract program to all of you to generate a contract. Okay. So in that case, what you do is you all, okay, since Pradeep sir is giving one contract, let us all run the contract. But I give one vulnerable smart contract to you. Then when you copy paste this program into your that software, it is telling you a warning saying that don't copy paste something like that. It become vulnerable. You may get your funds to be zero, something like that. You are telling still you are accepting. It's okay, no issues. Accept and then you run it. After running it, it found out that your entire fund balance becomes zero. The complete money or complete coins become zero because of the contract what I did. So what is your fault is you trusted the developer like me. So this is what the main happens in the blockchain. So trusting the blockchain managers and the developers. Next thing is the transaction speed. The speed of the transaction. In what time it goes? As I told you, 10 minutes it takes minimum. 10 minutes minimum for a Bitcoin. For a Bitcoin. Sorry. So 10 minutes minimum for a Bitcoin to mine. So that means for a mining, you need a minimum 10 minutes to mine a Bitcoin. So this is what happening in the transaction speed. So this risk, because within the 10 minutes, whatever be the miners thought, they can able to do that. So this is what happened in the transaction speed. Then malicious users, as we seen that there are so many adversaries, they call them up as a legitimate user, but they can be malicious. So legitimate, claim to be legitimate, but they are malicious. Malicious means they can able to do whatever they like within the thing. Then jurisdiction and dispute resolution. Now this is one of the major risk involved in the blockchain. See, you have some mistakes in your account. You have some uncertainty in your account or in your blockchain and in your node or in the block. Now you want to raise a complaint. Now where do you give the complaint? Who handles the complaint? Because blockchain is in virtually, it's available on a network with whom you can raise a complaint. Let's say if you want to give a criminal complaint or a cyber crime complaint, where do we give? So this is what the dispute resolution and the jurisdiction, and who respond you back. So who takes the responsibility? So this is what happening in the jurisdiction and dispute resolution in the blockchain. This is one of the major risk involved, because many a times when the blockchain owners or the Bitcoin owners or any cryptocurrency owners, when they lose their fund, they don't know where to complain. So this is what the happening with the disputes. Then use case applicability. Now people are thinking about everywhere we can use blockchain, but there are some use case applicability also there. and major access of it. So once you let's say you take example, you take your college. Your college have let's say 20,000 users. 20,000 users. I want to make all user to be in the blockchain. Let's say I want to develop a blockchain for all the users of my university. So that means I need to have a network like this. So 1, 2, 3, 4, 5 like this. I need to have a network like this. So all each block corresponds to one student or one faculty member, one faculty, one research scholar, and one alumni. So like that, I want to create a 20,000 records here. Now, how much computational resource I need to have? If I want to develop a blockchain for 20,000 users, I need to have how much resources? Now, this is what a challenge in the use case applicability, the risk. Okay. Now, simply we cannot say that, okay, 20,000 users easily. Now, think of, let people said that Maruti, they wanted to have a blockchain for all their customers who own their Maruti cars. Okay, now it is not a very easy task. They have to invest a huge amount of money for the computational resources. High energy demand will be there, so everything will be there. And some people have sold their cars. That means, let's say I use a car for 7 years. After that, I sold and then go for another car, another make and another brand. In their case, I will be in their blockchain also. Now, again, as per the concept, this blockchain node can never be deleted. That means the node will be idle, but it never be deleted. So this is what the property of blockchain. We cannot delete a node as easy as possible. So this is where the use case applicability of the thing. This is one of the greatest risk where how do we apply or where the blockchains have been applied. Then disaster recovery. Now this is a DR system. Generally, we have a DR system. So generally, whenever people say Google is down, YouTube is down, Instagram is down, Facebook is down, within 2 hours or 4 hours, the servers will be up again. So the disaster recovery is working just 4 hours or 2 hours or 3 hours. Now, what happens when a blockchain is down? So in that case, the disaster recovery, how long it takes for the disaster recovery? This is what happened that is in the risk, one of the greatest risk. Then finally, we have performance and scalability. So how do you measure the performance of a blockchain and how good it is scalable? Now this is where we need to rely upon the scalability issues and the performance issues of the blockchains. Okay. Now scalable means, now let's say one example here is let's say Vidya Vartaga, they having 7,000 users now. So they just to go for a blockchain now. 7,000 users with the faculty and students, they go for creating their own blockchain. Each block corresponds to one student and or one faculty member. They go for a blockchain. Now the next year they incremented the student strength. They increase the student strength to a total of 10,000 users now. Okay, now they wanted to increase 7,000 to 10,000 users. Now they don't have a computing resource. Now with the existing blockchain, can I able to increase to 10,000? Now this is where scalability comes into picture. Now, if it increase that, what is the performance of my system? What is my performance of my blockchain? Shall I have the same retrieval system? Shall I have the same hash coding system? How many miners will be there and who going to mine the data? So everything, I have the issue there. So these are all some of the risk when we go for opening or when we want to create a blockchain there. Okay. So cyber threats and the risk involved in the blockchains, I just covered almost all the aspects of it. So now, whenever you do or any kind of work or any kind of research, you can always think of how that can be. I mean, this risk and cyber threats, how can be judged before we start any application in the blockchain domain. Okay. So now let's see some reality. So